Okay, so we moved on to chapter 8. We're on vector and parametric equations of a line in R2, so in two-dimensional space. So when we're working with our Cartesian plane, it's essentially just x and y. And we'll go on later in the chapter to deal with this in 3 space. So we've come up with quite a few new symbols and variables. Vector equation. So the equation of the vector is equal to vector r naught plus t m vector. What is going on? Okay, so again, vector. The equation of a vector, vector r is equal to vector r naught plus a scalar, or they call this a parameter now. We know it as a scalar, multiple of a vector. And m is our directional vector, such that the scalar is all real numbers. That's all this means here. What it's really trying to say is, as long as we're really not dealing with 0, we're okay. Okay. This is broken into component form for the vector equation. So these would be the actual points on the graph we're talking about. So vector r, these are its 2 components. Vector r naught, these are its 2 components again, such that the parameter, or as we talked about before, the scalar of this directional vector. Before we get into the parametric equation, so vector r naught is the vector from the origin to some point, represented by x naught and y naught. And that's what they mean by this parameter here, and that's what this vector is a vector, and we're going to draw or sketch an example of it in a minute. And m is the directional vector with its components a, b. So it lets us know which way all of these vectors are going to be going. Okay. So the very first equation in 8.1 is on page 427. We're going to jump over and we're going to talk about that. So the question says a line is passing through 2 points. One point is P, 4, and 3. And he has a directional vector of -7 and 1. Okay? Sketch this line. So we're going to bring up our graph quickly. Here we go. And they want us to sketch this line. Okay, so first of all, we want to figure out the directional vector. It's going to tell us what direction everything's going. We know where the point's going to be. It's very easy to find. We go to 4 and 3. Here's our point there, point P. Okay? But from there, I can draw any number of lines. I could go up this way, this way, this way, and so on, right? We have an infinite possibility for where these vectors can go from that point. The directional vector is going to tell us the direction, and then we're going to apply that vector to make sure it crosses through this point. So directional vector, where does it start? Does anyone remember? At the origin. So we're going to start at the origin, and from the origin, we're going to go -7, up 1. Okay? So it gives us the exact point it would be, because the vector is always going to start from the origin. So when we go to draw this vector, that is our directional vector there. Okay? And it stands for vector m is equal to -7 and 1. Okay? Now, you guys have dealt with this a long time ago. Anyone have an idea what this might stand for? They used the letter m also, just they didn't call it a vector before. Slope, yes, this is very, very similar to slope, okay? But just remember, when we're talking about vectors, not only do we have a direction, which is slope, but there'll be magnitude to these also, okay? So, I have to essentially draw the same slope across this point P. So if you guys remember, rise over run, you guys remember that at all? It's the same idea as our directional vector is going to kind of give us our rise over run. This is our x value, and this is our y value of the directional vector. Anyone remember rise over run, which goes on top of the other in terms of x and y? Y would go on top, and x would go on the... So, if we were relating this back to slope, now remember it's not called slope, this is direction of the vector, but if we were to relate it to that, how can I represent the direction or slope of this vector? As a fraction. Negative, not 1/7. Oh yes, I lied, 1/7. Thank you. Okay, so that's exactly it. So that means we rise up 1 and go to the left 7. So we go up 1 and we go 1, 2, 3, 4, 5, 6, 7. Pretty straightforward concept when you guys try to think of it in that line. The other way we could have done it is we could have gone down 1 into the right 7. 1, 2, 3, 4, 5, 6, 7, right? But what was the direction of our vector? Was I heading essentially to the left or to the right? I was heading to the left, okay? So remember, lines go indefinitely. They go on forever. But in terms of our vector, and don't get me wrong, I could have started from back here and gone all the way up. Our vector was heading in this direction. That's why we start at the origin. So we know that there's a direction to this. It isn't left or right. It is heading in the general direction of left right now. Or northwest, you could say. Okay. So that's the very first question, sketching this. We've now sketched the point and the directional vector going through that point. Question B, we'll try to do it on the same page here, or example B. Example B says a line passes through point A. So point A is at a half and -3. And point B, so it passes through both of these points. Determine a direction vector for this line and write it using integer components. Okay. So we have to find a direction for this vector, or a direction vector, which would essentially be our m vector here. And they also want us to write it in component form, okay? Which is, this is our component form with our 2 points on the Cartesian plane. So if we're going to figure this out, we have points A and B. We're going to do a rough estimate of what they look like on here. We'll do it in purple here. A is at a half, y -3. So that's probably where point A is. Point B is 3/4 and a half. Something like that. Okay? Now we're going to try to actually find, determine a vector equivalent to either, oh sorry, they did give us parameters, which is important because remember we said we were going to have direction. They want us to find direction vector for either vector AB or vector BA. Okay? So we're going to choose one of them. Now this is important. Remember we talked about the way the vectors were written in the first place. This is going to be our starting point, and you could say our ending point, but in other words, that's the direction we're going. Okay? So if I'm starting at A and going to B, I'm heading in a northern direction. But if I'm talking about vector BA, we're still going to have the same magnitude, right? The only difference is this is heading in a more southern direction. And that's going to be important for what we're doing. So I'm going to actually solve it for just one of them. We're going to work with AB. I'm looking for vector AB, direction. And if you guys remember, if we're looking for vector AB, the directional vector, heading up that way. If we're looking for that, we're looking at essentially x2 minus x1 and y2 minus y1 as our components for it. Okay? So we're going to plug these in. X2, which is going to be our B. Our B needs to be our x because it's the second point we're talking about, or sorry, our second coordinate. X1, Y1. So X2 is 3/4, and X1 is a half. Y2 is a half. Subtract -3. These will be our components. This is going to be 3/4, subtract 2/4. And here we're going to be left with a half plus 6/2. So, whoops. Fourth and 7/2. Okay. Did I write this all in properly? Yeah. Oh yeah. BA would be the opposite direction. So our directional vector, or our M, for AB is 1/4 and 7/2. So in other words, what they're saying is if we started from the origin, this is the point we would need to get to. Okay? So starting at the origin, our directional vector would go 1/4 on the x-axis and 7/2, or 3.5 on the y-axis. So we'll try to put this one in maybe blue. What did we say? It was a half and 3.5. So something like that for our directional vector. So let's put this in color blue. Our vector m for part B looks like that. Should be identical. I clearly didn't draw it properly in the first place. But that's the idea. We're still heading in the same direction. One of them starts at the origin. The other one includes the points talked about. Okay? But still heading in the exact same direction.